Hey, welcome back. And in this short video, what we're going to cover and start introducing is this concept called agents inside of LangChain. Now, agents are really fascinating and they're very good at doing task planning, for example, and executing lots of different things in a very dynamic way. But before we go into any code, I think it's worthwhile us thinking about some high-level concepts that LangChain provides. So you've got this idea of an agent action, which is what you might decide a tool that's going to be used, and we'll talk about tools in a bit. When the agent is finished, so there's this idea of that eventually the agent is going to finish and that it will return some result. Now there's some series of intermediate steps, and if I scroll down a bit and show you, you can almost think of an agent like this, where the agent gets an action, and when the action isn't to finish, we then run the next action, and then we get an observation, and with the observation, we then decide to get another action. So we've provided it almost like an endless loop of actions, observations, getting the next action, and then whilst the next action isn't to finish, we keep running in this endless loop. So that's a little bit on agents and the concepts that are happening here. Now, as you're probably all aware of, agents use something called tools. And tools, if you can think of it, are basically just Python functions or some way to interact with the environment. Now, if we have a look at tools, there's a variety of different ways that you can define tools. You've got some default tools that are provided to you from the LangChain documentation. But essentially, in essence, a tool is basically a function that you can have an input into, and there's an output that gets added, right, from using the tool. LangChain provides some really great ways for us to create our own tools. And so what we're going to do is have a look at how we can create tools and how we can attach those tools to LangChain agents. And then the agent can then use those tools to answer questions. So let's have a look at this notebook, and to start with, we're going to use the LangChain community.tools, and you've got two tools here. So I'm just going to make sure my notebook's running, and I'll just run that. So let's have a look at this. So what we're going to do is have a look at this one here. All right, so in this example, we're using a community tool, which allows us to query Wikipedia. And you can see there's this API wrapper, and then we have this tool that's being made from the Wikipedia query run. And this eventually will basically make a tool. Now we know it's a tool in LangChain because if it's got a name, a description, and some input arguments, you can see the tool name is called Wikipedia. This is the description. You've got the query, so this is the args that will go in, and this bit here is whether the tool will automatically be returned to the user or whether the agent will take the output of the tool and then decide what to return to the user. Now, how do you call a tool? Well, you can just do the tool.invoke, and you can see if I run this, it's going to start using that tool, and it gives us some information about digital marketing. Now you can see it's got a doc content chars max, so we could also set this to 1,000, and then we're going to get a lot more content back about that example. Now, one thing that's often the case is you'll want to create your own tools, and your tools are going to need a name, a description, and an args schema, which is optional. The name is required, and so the two optional ones are the description and the args schema, but it can be really nice to include those. Now, the first way that you can easily create a tool is you could have a Python function like we're going to do a Google search, and we could take a query in here. Now, for now, we're just returning LangChain, which is a type of string, and we wrap that specific Python function with this tool decorator. And then based on that, you'll then, from the doc string, it will add that into the description. So your doc strings, you want to make them very descriptive about what kind of tools your agents can use. The name of the tool comes from the Python function that you can see here, and the args schema, or the .args in this case, get associated with the query. And this is basically the function signature. So you've got one input parameter here, which is the query, which is the type of string. Now, you could also modify your inputs, and so you can see here we've got a Pydantic model, and we have one input which is a query type of string, but we've also added on a description to make it a bit more descriptive. And you can now see we've also changed the name of the tool to search tool, and we've also said that this output should be immediately returned to the user and not the agent if it's the final finish. So You can also make tools from the search function in terms of a structured tool.from function, where the function is here, you give it the name and the description, and you can even add on the arg schema and all that good stuff. Now, this shows you how to make tools, but let's see how do we add these onto agents. The easiest way to do that is you would have some function. So for example, we've got the get word length, we'd make our list of tools, and we call that a tools list. And so what you end up here with is you've got that tools -list, which has a bunch of tools. Now, once you have your bunch of tools, I personally find that the best way to use these LangChain agents is to write your own custom agents. Now, it's quite easy to do that. There's a couple of different things that you'll need. So the first is you'll need a chat prompt template, and then you can have whatever you want in the system message. You need some form of input to take the original query. And then this is the most important bit that you have to have if you're building your own custom LangChain expression language agents. And basically this agent scratchpad is how LangChain will store all of those actions and observations so that it can use that in memory to then decide what to do next. Because remember, there was that endless feedback loop of do an action, get an observation, decide on the next action. Have we finished? Oh, we haven't finished. Let's go and run that next action again until you end up finishing. So that agent scratchpad is really important because that stores all of the kind of intermediate steps that LangChain uses. And remember, the input here is basically what you can use to specifically decide on the first query that hits this agent. Now, after defining the chat prompt template, you'll then need to bind tools to your agent. And basically, OpenAI have recently moved away from function calling and they've moved to binding tools and using tools directly. So we use the .bind_tools function, and that takes a list of tools. And you've got a model, and your model also needs to be capable of calling tools. Now, once you've got your model and you've bound the tools to that specific model, it knows about those tools, but we still need to set up the formatting to easily convert the intermediate steps that are inside the agent scratchpad into something that OpenAI understands. So what's happening is these intermediate steps that the agents have scratchpad down, I've taken this action and run these tools, it's formatting those to the OpenAI tool messages. And then after that gets put into the prompt, we then have the model that is with the tools, and we also pass the tools output back into these intermediate steps so that the agent executor can easily understand those and see what's happening with those. So after you've got your agent set up in an LCL chain, you would then add that on to the agent executor. You also pass the tools here, and you can also put in verbose true to make sure that comes across and you can see all the various steps. Now, if I just .stream the output, and you can see the input is going to be mapped, if we scroll back up, to this input here in the user message, and we're saying something like, how many letters in the word data? And by doing agent executor.stream, we can actually see all the different steps that happen inside of the agent. So you've got the actions, it decided to take a tool, that agent action, and it used this get word length tool. And we can also see what the final output is. So the word data has 4 letters, and this is the messages that ended with. Now, you wouldn't always stream these, and the way that you would normally use these if you just wanted to get the final output is you would use that .invoke function. And by changing that to the .invoke, you'll see that we just get the final output, which will come through in just a second. So you get this input, how many letters in the word data, and you get the output. The word data has 4 letters. Now, that's great, but we don't currently have any memory inside of this agent. It can just use a tool, and it can use that to help solve a question. Now, one thing that we can do to add memory in is we can add another messages placeholder, and you'll see we've got 2 messages placeholders. So one for the memory key, which is we've called chat history. And that chat history, that key name, the variable name here is very important. And you'll see this has also got our agent scratchpad. Now we create a Python list called chat history, and we updated the LCL chain. So basically we're getting the chat history, and then that's then being formatted into the prompt. So you've got both the chat history and the agent scratchpad that are now being associated with these message placeholders. Yeah. So you can add as many message placeholders as you want, but you have to make sure that before that enters the prompt, you've got some output for those inside of your prompt template that goes into the prompt. Then it goes into the model and we pass back the agent tools agent using an output parser. The agent executor is exactly the same, but you'll see we've got this first input, how many letters in the word data, and we've now had to add on that chat history as the extra one, which is just a Python list. Now, we then extend the chat history with a human message with the input one and the AI's message that it came back with a result output. And then we can say, is that a real word? And so we can have a look. So firstly, it's going to figure out that it needs to invoke this tool called the get word length, and it uses the input for that as data. And then it basically, this is the output it came back with. So the word data is 4 letters. And then after that, then it entered a new agent executor chain. But rather than deciding to invoke a tool, it decided to just reply with text. And that's quite an interesting thing because you don't always have to invoke tools when using agents. They can use a mixture of just replying in text or using a tool. And in OpenAI tools, you can also run multiple tools in parallel, which can make agents incredibly versatile at not only being able to handle certain queries, but also being able to handle a mixture of queries. And we can see that the second response is saying, yes, data is a real word. It refers to facts and statistics collected together for reference or analysis. So it is actually referring back to the fact that we asked it a question about is data, what's the data, and sort of what's the count for that word. Now, one thing that can be quite nice to do is, obviously we've done this, but I just thought I'd show you another way of doing the memory. You could create, so when we're building these chains, they are something called a runnable, and a runnable is something that can be ran. It's a LangChain expression that's basically compiled into a graph. Now, if we go back down here, we can also do something like this where we can create an empty store, which is going to store our chat messages. And we can do something with runnable with message history, and we can specify a session ID. And so what you'll see here is we've changed the variable name to history just to show you how this works. The agent chain therefore has to update and it has to use history. The agent scratchpad stays the same. And what we've also got here is a get session history that takes the session ID, looks inside of that Python dictionary, which is the store. And then after we've looked inside of that Python dictionary, we add on that session ID and we create this chat message history. And then we return the session ID. Now, we can then wrap the agent executor with that Python function, and the input messages key is going to be the input. So remember, that's our input here, and you can see that in the ACL inside of this agent chain. Now, and the history messages key is the history. Now, once we've done that, now what we can do is we can invoke, put our input the history, set the config for the runnable config, and we say it's configurable with the session ID, some session ID. And what's happening now is the store, if we have a look at it, is actually going to start to be populated with a session ID, which has a chat message history attached to it. So this is an in-memory way of doing configurable chat message histories, which is being associated with this specific dictionary, this Python dictionary, this store Python dictionary. Now, if we then say, I've told it my name is James, and now we can also say, what is my name? And we're using the same session ID, which we've called some session ID, and the agent executor hasn't used any tools here. It's still got the ability to count with the word length, but it's decided to just reply in text, and I think that's an important point. And you can also see here that because we're using the same session ID in our runnable config, we've then also been able to then get the LLM to store that chat history in a in-memory Python dictionary, and the output then says your name is James. So it is able to remember who we are by using that with message history runnable. Now, if I change the session ID to something different, you'll see that we then get a very different response from the agent where it decides, you haven't mentioned your name yet, please could you tell me your name, and I'll remember it. So hopefully this gives you a good introduction to agents. In future videos, we'll be exploring how you can build agents directly inside of things like LangGraph, and also how you could build multiple tools and looking at parallel tool usage.